Good evening, everyone. So, welcome to today's session, which is on algebra practice. This session is brought to you by me, Nilanjan Dutta, a CAT 100 percentiler, one of the topmost educators on Unacademy and Unacademy Plus for the CAT and the MB exams segment. This is a brief about myself, and I wanted to inform all of you about that you can subscribe to the Unacademy Plus CAT subscription using the code Nilanjan Dutta, which includes access to the Perfect Score batch, which is happening on every Saturday and Sunday at 10 a.m. This is the batch where I teach the quants portion. To get access, you can use the code Nilanjan Dutta while subscribing, and make sure that you're sharing the screenshot of having subscribed using the code Nilanjan Dutta at the following number so that you get eligible for a personalized mentoring initiative across the period while you're subscribed. That includes getting mock PIs as well at the end of the GDPI season if you're subscribed during that period. So make sure you're going for either the 12 or the 24-month subscription and sharing the screenshot at the following number 8102126799. That also includes the CAT 2020 weekday evening batch for the full syllabus where I'm covering the iler portion. So there you can use the code Nilanjan Dutta while subscribing. Remember, it's one subscription. You just need to enter the code once, go for the 12 or 24-month subscription, share a screenshot at this number, and then enjoy the period. So with that information in mind, let us move into today's practice questions. So the first question is as follows. Here it says, if the product of k distinct positive numbers is k to the power k, then the minimum possible value of the sum of these k numbers is which of these options? So everybody try solving this in the next 1.5 minutes, and then we'll look at the approach. So how do you do such questions which are on maxima minima? As I've always said, in any maxima minima question, all you try to do is equate the terms. So if they are saying k distinct positive numbers is k to the power k product, try and break them into as equal terms as possible. And then try doing a sum of those almost equal k numbers. So your options are as follows. So try taking a minute or minute and a half and answering the first question. So how do we solve this? As I said, keep the k terms as equal so that you get k to the power k. So the easiest way is keep each of the terms equal to k. That is, all the terms are equal to k, which means the product is k to the power of k. So basically what am I doing? I'm adding k numbers, each of which are k. So I'm adding k numbers, each of which are k. The product will be n, that is the number of numbers, that is k, into the average of all the numbers, which is also k, which is nothing but k into k, that is k square. Hence the answer is option D. Now somebody wondering, what about the fact that it's mentioned distinct numbers? Note, it might seem that these numbers are not distinct, but that is the reason why the sum of these k numbers will be greater than k square and not greater than equal to k square. But the answer will still be k square, because remember, if I take the numbers as k plus 0.000001 and similarly another number as k minus 0.00001, then remember the product will almost be equal to k to the power k still, and the sum will almost be equal to k square still, even though these two numbers will be considered as distinct. So even though the question says they're distinct, what you can do is assume that they're equal, because remember, even though these two numbers are distinct, they're almost equal in value. The only effect of the distinct word is that the answer will not be equal to k square, it will be greater than k squared. Had it been same numbers allowed, then it would have been greater than equal to k square. But anyways, for this question, the answer is option D, that is k square. Second one, so this is a previous year CAT question and a pretty popular question from the previous year's CAT. So how do we do this? Again, take a minute or minute and a half to figure out an approach for this question. So what you can do is just look at the first term and check what it is coming out to be. So break it into smaller terms and check. How much is the first term? 1 plus 1 by 1 squared, that is 1, plus 1/4, which is nothing but root over of 2 plus 1 by 4, the root over of 9 by 4, which comes out to be 3 by 2. If I want to express 3 by 2 in this form, what do I write it as? I can write 3 by 2 as 2 minus of half. What is 2? 2 is this term. So the answer is basically this term minus of 1 by this term. Whereas in the final expression, the final term is of the form 2008. So basically that should ideally be of the form option 1, 2008 minus 1 by 2008. Similarly, if I look at the sum of the first two terms, how much is that? The first term is 3 by 2. The second term is root over of 1 by plus 1/4 plus 1 by 9, which comes out to be root 49 by 36, which comes out to be 7 by 6. So now if I add the first two terms, 3 by 2 plus 7 by 6, I end up getting 9 plus 7, that is 16 by 6, which is nothing but 8 by 3. 8 by 3 can be written as 3 minus 1 by 3. So again, it is this term minus the reciprocal of this term, which means Similarly, if I go up to 2008, the answer should be 2008 minus of the reciprocal of 2008, that is 2008 minus 1 by 2008. This is exactly how the first option is defined. So as you can see, all you need to do was simply look at the options and see which of the options is of a somewhat similar form to whatever is mentioned in the basic question. So look at small examples and then extrapolate that pattern for big numbers. For example, if I extended this series up to 7015 as the last term, the answer would have been 7015 minus 1 by 7015 and so on. So that is all you needed to do in this question. So again, it's all about spotting patterns. So you noticed in the first question, again, all we did was k numbers, each of them k into k, that is k square. We immediately mark the answer. In the second case, again, what we are doing is not solving it completely. All we are doing is looking at a small example and marking the answer. The main key thing is getting the answer in any way possible. You need not always solve the question completely. Is that clear? Third one, 5 to the power p minus 3 to the power q is equal to 122. 5 to the power p minus 1 plus 3 to the power k plus q plus 1 is equal to 34. Find the value of p square plus q cube. So again, first you need to find the value of p and q, and then you can find the value of this expression, that is p square plus q cube. So again, take a minute or minute and a half to solve this. So first try and get the value of p and q from these two expressions, and then look to get the value of p square plus q cube. So how do we do this? So the first thing, if you look at the second one, you need a power of 5 and a power of 3, which adds up to 34. So what are the powers of 5 possible? 5 to the power 1 plus 29 is equal to 34, but 29 is not a power of 3. 5 square plus 9 is equal to 34, and the good thing is it is also a power of 3, which means this expression must be nothing but 5 square plus 3 square equal to 34, which means p minus 1 is equal to 2, p is equal to 3, q plus 1 is equal to 2, which means q is equal to 1. So what does this expression become? 5 to the power p, that is 5 cubed, minus 3 to the power 1, that is 125, minus 3, which is indeed equal to 122, which means the value p equal to 3, q equal to 1 is satisfying. So now that you've got the value of p equal to 3, q equal to 1, you can simply put it here and check. What is that? 3 square plus 1 cube, so that is equal to 10. So 3 square plus 1 cube is 9 plus 1, that is 10, which means the answer to this question will be option A, that is 10. So again, that's the simplest way. Look at 34, look at ways of breaking 34 into the sum of a power of 5 and 3. So that is 25 plus 9, 5 square plus 3 square. Put p minus 1 as 2, that is p is equal to 3. Q plus 1 is 2, that is q is equal to 1. And solve. So that will be nothing but 3 square plus 1 cube, that is 9 plus 1, that is option A, which is 10. So use the discount code Nilanjan Dutta while subscribing to Unacademy Plus. As you are aware, there are 2 courses running right now. One is the weekday evening batch, which is happening tonight as well. We have a class at 9 p.m. It's a 9 p.m. daily sessions, as well as the Perfect Score batch. For either of the courses, when you're subscribing to Unacademy Plus, subscribe to the 12-month or the 24-month subscription plan. Use the code Nilanjan Dutta while subscribing and share a screenshot at this number 8102126799 so that I can add you immediately to the respective courses, as well as the other benefits that you get are subscribing using my code. So any questions, anybody? The third question is a question on logarithms, and it goes as follows. Log 58 minus 3 to the power z base 7 is equal to e to the power ln 4 minus z. Remember, ln is nothing but log base e. So here ln is nothing but log base e. You need to find out the value of z. You have the options. The easiest way would be to put the options and check in which case is the value z satisfying. So try solving this in the next 1.5 minutes. So how do we solve this? One hint, any term of the form this where this is e and this power is also the same for the base of the log, you can represent it as the 4 minus z. This is true for any term where this and this is same. You can represent it as 4 minus z. You can represent RHS as 4 minus z. So simply look for in which case is log 58 minus 3 to the power z base 7 equal to 4 minus z. So these are your options. Z is 1, 2, 3 and 4. Also remember, the moment you have log 58 minus 3 to the power z base 7, it means this term must be a power of 7. So if I put z is 1, I get 58 minus 3, that is 55, which is not a power of 7. I put z is 2, I get 58 minus 3 squared, that is 58 minus 9, which is 49. And now we know log 49 base 7 is equal to 2, which is equal to 4 minus z, where z is equal to 2, which means basically if z is equal to 2, then not only is the left hand side satisfying, but the right hand side is also satisfying. Both LHS and RHS become equal to 2, because at z equal to 2, this becomes log 49 base 7, which is 2, and this also becomes 4 minus z, that is 2. So basically the question is asking value of z. The value of z is option B, that is 2. Is this clear to everybody? How you are putting in the values from the options and checking, and this is the easiest way to solve every question on logarithms. Next we move on to the final question for today. So this is a polynomial function of degree 5 such that the coefficient of x to the power 5 is 1. It also the values of f1, f2, f3, f4 and f5 are given. The question is asking the value of f6. This is a pretty challenging question to solve by the normal conventional approach. So it might be wiser to go by the options based approach in this kind of a question. So take around 2 minutes to try and figure out the best possible way to solve this question. So how do we do this? Look for patterns here. All of them are increasing. All the terms are increasing. This is 4.9 times. F2 to F1. F3 to F2 is 3 times. F3 to F4 is greater than 2 times. F5 to F4 is just less than 2 times. So F5 to F6 is ideally be within 2 times of F5. So the answer should be little less than twice of 586. That is less than 1200. But at the same time, it should obviously be greater than 586. Greater than 586 and less than 1200. So try and figure out which option falls in this range. So if you try and do that, there will be only one option that falls in this range of 586. Greater than 586 with only 2 options. Out of that, within 2 times of 500, within 1200 is only option C. So that is the one you should be marking and going forward with. Is that clear to everybody? Any questions on any of the ones that we discussed so far? So I'll just pause for a minute in case anybody has any questions on any of the ones discussed in today's session. So reminder, use the code Nilanjan Dutta while subscribing to the CAT subscription plan. Hope to see all of you on Saturday, Sunday at 10 a.m. Use this code and send a screenshot. Also tonight we have at 9 p.m. which is the daily weekdays evening batch. So this is a new batch that just got started. So do make sure all of you are attending them. Use the code Nilanjan Dutta while subscribing. Share a screenshot with us. So then, if there are no more questions, then thank you everybody and happy learning. So just make sure that each of these questions you are understanding the shortcut approaches used. So this one was more of equating, this one was more of looking at the options, this was more of putting in values from this expression, this was more of value substitution looking for powers of 7, and this was more of looking at the numbers and the range in which F6 can fall. So that is a way to going about quants in a much more shortcut fashion. So we'll again connect for the next session soon. Till then,